This lesson is for FST, Lesson 5.3 on the Law of Cosines. It will be real important for students to pay attention to what type of triangle they're looking at when they start any triangle problem. If it's a non-right triangle, one of the things you might use is the law of cosines. How do you know when to use the law of cosines versus the law of sines, which we're going to learn in a future lesson? The law of cosines is only used in two instances: if the triangle is set up as an SAS or SSS triangle. SAS and SSS are two references back to geometry. SAS means two sides are given and the angle between them. SSS means side, 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 and that simply means all three sides are given. So we're going to look at examples of each of these. The law of cosines itself resembles the Pythagorean theorem with a few extra pieces. So the law of cosines is little c squared equals a squared plus b squared minus 2ab times cosine of big C. Big C is labeled as a capital letter here because capital letters are representing angles. Capital C matches or is across from little c. Little c is the side across from big C. So make sure you make that clear in your notes. Big C and little c are across from each other. And if you need to, also indicate in your notes that the C is the side length, where big C is the angle measure. So if you look at this example that's listed here, the first one, we've got side, angle, side. Two sides are given and the angle between them is also given. So I'm going to label the angle that I'm given, big C, the side across from it, I'm going to change to little c. So if I'm trying to find little c, that means the two sides I'm given are A and B. A and B are interchangeable, by the way, so if you listed it as B and then A, it would still work. So when I plug in the numbers here, I'm going to say 120 squared plus 90 squared minus 2 times 120 times 90 times cosine of 10 degrees. Make sure you're in degree mode on your calculator, and you would literally just type in everything you just wrote in one big long strip on your calculator. So let me show you what I mean. Here's my calculator. And I typed in 120, I'm in degree mode. I'm at 120 squared plus 90 squared minus 2 times 120 times 90 times cosine 10. I typed all that in and hit Control Enter to get a decimal answer. Notice that when I took that number and did the square root of it to get just plain C, notice that the calculator included some more decimals. So you don't just take this number as is, you want to do square root and then you want to hit Control negative. That'll grab the previous answer including extra decimals that you weren't able to see before. And so then we're just going to round that off to about 35. So we got c squared is 1228.15, and then to solve that we square rooted on both sides. It is possible for students to type it in with a big square root to start with and get just the value of c in one step, but I found that kids make fewer mistakes if they do it in two steps. So I'd recommend typing it all in after you've substituted in all the numbers and then just square rooting your answer, and then just pay attention to what they tell you to round to. Also pay attention to any labels if they are present, like centimeters or inches. You would want to include those as well. I want to point out one other thing before we move on to the SSS setup. On this question here, they ask us to find side BC, which would be this side over here. According to how we would normally label this, however, the little a side would actually be over here. So you have two options for how you can set this up. This is an SAS setup, but the angle we're used to calling big C, and here it's labeled as big A. So if you want to, you can set up your law of cosines with the A as the thing that you're trying to find, and B and C as your two sides. So you could list it out this way instead, and then you could plug in A and B that way, or excuse me, B and C that way. So this would be another option for you. It's the same formula as what we started with, but typically we have the C here and the C there. But that way it mimics the Pythagorean theorem, because we're used to saying a squared plus b squared equals c squared. But if you wanted to set it up this way, that's perfectly fine. The other option is you can go ahead and just relabel it. So if you don't like this, if that confuses you, just relabel this as C, little c, this is A, this is B, and then you could just do the Pythagorean, or excuse me, the law of cosines as you're used to. So that problem is there for you. I'll pop up the answer here in 2 seconds. If you want to pause the video, you can give this one a try and I'll show you the answer here. So here you go. If you set it up, you end up with getting, after you've square rooted, you get about 17. The next thing I want students to try is one problem on their own. So go ahead and give this a quick copy. And I'm going to just scroll down here and reveal the answer. So pause the video, give this a try, and the next thing you'll see will be the answer. So when you label everything here, I purposely labeled this B and that A. It would still work if you had your 18 listed first and your 25 listed second. You should still get the same answer. It did say round to the 10th, so if you don't have a 0.4 there, it would be counted wrong. I want students to look at one quick thing with me. Just want to do a little quick review of Algebra 1 here. Just a quick reminder for students that if you're solving for x here, you don't add those two together, right? 4 minus 3, you wouldn't want to say 1x there. Most students know that when you have that, you should not subtract because of, number one, the order of operations. The multiplication here takes priority over the subtraction. The other reason you wouldn't want to combine those is that they're not like terms. One's got an x and the other one doesn't, so you wouldn't be able to subtract them. So the first thing you would do here, if you were asked to solve, again, I know this is super easy, this is back from Algebra 1. Be careful here, oftentimes students will forget to bring the negative with the number. Make sure you bring down negative 3x. Next step should be to divide. Common mistake here is for kids just to divide by 3. Hopefully you're noticing right now that, hey, when you're dividing, you need to divide by the negative number, because what that does is it gives you a 1, which is next to the x, and that's what we wanted. So keep those basic steps in mind. Don't subtract here, you want to add the opposite instead. And then when you're dividing, make sure you bring down any negatives, and make sure when you divide you bring the negative with you. So keep those steps in mind. We're going to use that to look at SSS setups for the law of cosines. So let's review the law of cosines. Say it with me as you write it. C squared equals A squared plus B squared minus 2AB cosine, very good, big C. So this is going to be an SSS setup, which means all three sides are given. That's the only other time that you would use the law of cosines to solve a problem. There's one other piece to this question that I want to touch on. It does say find the measure of the smallest angle in the triangle. The smallest angle is always going to be, this is from geometry, across from the shortest side. Now that's true on any triangle, not just on this particular one. It also works if you deal with the largest angle. The largest angle is going to be across from the longest side. So that's an idea that you can utilize moving forward, not just on law of cosine problems, but on any triangle question. When you're setting up law of cosines for SSS, figure out which angle they want you to deal with. In this case, we're finding the smallest, so they want us to deal with angle B. So we're going to try to find angle B. So that means the side that has to be across from it has to be the 8 side. So the 8 side is actually going to go over here. And then the other two sides are my A and my B. Alright, so the smallest angle is across from the shortest side. So that means the 8 has to be where the little c is located, because little c is across from the angle. And then the other two sides are the A and the B. So finish off writing out your work here. And I'm going to call it cosine B this time, because B is the name of the angle. If you wanted to call it cosine C, that would also be perfectly fine. Now when you calculate here, there's some order of operations that you need to worry about. First we're going to worry about our powers. And we're going to go ahead and add here as well, because these are going to end up being like terms. They're just regular old numbers, so we can go ahead and combine those. We're also going to do next after that, we have some multiplication here that we're going to deal with. So let's go ahead and calculate there. 8 squared, 64. 12 squared is 144. 10 squared is 100. 144 plus 100 is 244. Leave the minus sign there. We'll worry about that later. 2 times 12 is 24. Times 10 is 240. And then we still have cosine B left. This is a spot where kids make the most mistakes on the law of cosines. Doesn't it feel like we should be able to do 244 minus 240 there? Doesn't that feel like that would very easily make a 4? But remember the question that I had you guys do earlier with me. Would you subtract 4 minus 3 there? Absolutely not. The same principle applies here on this one. The only difference is we have a cosine in front of our variable, but it's still multiplication, so these are still not like terms. So instead of subtracting these two from each other, instead we're going to take away the 244 from both sides. We're trying to solve for b, so we're moving everything out of our way. When we do that, we get 180 on the left. Don't forget, bring down the negative. Now, to solve and to try to get b alone, now we're at this step right here. We've got something next to the thing we're trying to find, so we're going to divide by that on both sides. So we're going to divide by negative 240. And when we do that, we get about 0.75 equals cosine of b. Final step is to get rid of the cosine. Students learned yesterday with me in lesson 5.2 that to get rid of a cosine, you use an inverse cosine. And the equation remains balanced if you do it on both sides of the equation. On the right-hand side, the cosine and its inverse will cancel. Over here, you'll have to simply type that in on your calculator, and you get about 41 degrees when you do that and round it off to the whole number. So I'm going to have students try that again on their own. This time you're not worrying about which angle is the largest, you're simply finding the measure of angle C. So that tells you this number, the 15, has to be the one that's all alone. Give that a try, the answer will appear shortly. So the 15 has to be the number that's on the other side of the problem that's all alone. The 13 and the 11 have to be the A and the B values. Again, be careful here. When you get 290 minus 286, don't subtract those. Feels like you should be able to, but you can't. You're going to move the 290 to the other side by adding the opposite and then divide by negative 286. Don't forget here you will have to do a inverse cosine. I do want to try this problem with you on my calculator just to illustrate how I got this answer. So I'm going to show the answer here in just a sec. So let's go to the calculator. So I did 65 divided by 286 and I got this decimal. Now I'm going to do the inverse cosine of that answer. To get that answer, including all the extra decimals, even ones that aren't showing, I do Control and then the negative key. That gets me my previous answer. Now when I hit enter, it fills in all those extra digits for me, and now I can see that I got 76.9 if I round to the 10th. Again, it feels like we should be able to round that up to 77, but the directions say round to the 10th, so this is the correct answer.